know, I love the fact that this is so science-based. And that's why you reached out to somebody like Dr. William Dunn, right?
That's right. Dr. William Dunn is one of 3 researchers around the world that has devoted his life to the science of autophagy.
Wow.
Autophagy means cellular self-cleansing, cellular self-eating. It is such important research that it won the Nobel Prize in 2016.
Wow. Take a look at this.
Dr. Dunn, it is an incredible honor to have the opportunity to learn from you and the research that you've done over your entire career around autophagy. Can you tell us a little bit about what first got you interested in autophagy?
So basically, I started, got my PhD at Penn State University, and I sort of was interested in autophagy then a little bit, but we weren't really doing anything like that. Did a postdoc at Albert Einstein, then moved to Johns Hopkins. But anyhow, when I was at Hopkins, I had to find a different direction to get away from the lab I was in. So I decided we're going to go do autophagy because at that time, autophagy needed a different angle. Everything that was looked at in autophagy was biochemistry, and I decided to go to the cell biology part.
Okay, so tell us a little bit, sort of like in a nutshell, what is autophagy? And we're going to talk more about this later, but the Nobel Prize in Medicine was won just in 2016 for autophagy. So how many years ago, roughly, did you first get interested in autophagy, and then define it quickly for us?
I got interested in autophagy over 30 years ago.
Wow.
Now, it was defined by Christian de Duve back in the 60s, 1960s and such. And he identified it based on morphology, just looking at the cells by electron microscopy. And he actually was able to see these vacuoles, which were unusual. Mm-hmm. And Christian de Duve, who won the Nobel Prize also by identifying lysosomes,
wow.
And some other organelles, but predominantly lysosomes. And he did this by a variety of methods, but the first method, one of the best methods, was electron microscopy, where you could actually visually see the cell and look what's in the cell. So we found these unusual structures, very unusual structures that were membrane bound, that were within the cell. And these structures had cell components in there. So he came up with the idea of autophagy, or self-eating.
Yes.
So the cell was actually eating itself. It was grabbing itself, its organelles, its cytoplasm, parts of itself, and putting them into vacuoles, which would then end up in the lysosomes.
So if I were to sort of give an analogy almost, within the house, which is like the cell, right? So if we're in our house, the autophagy is essentially doing the housekeeping within the house so that the house sparkles and is looking beautiful, and ultimately for the cell, it's in its most healthy form. How would you what analogy would you give us?
So basically, I mean, when it was first examined by de Duve, he just thought it was pathology. He really thought there was something wrong going on in the cell. This is not a normal process.
This cleansing.
This cleansing, or this self-eating.
Self-eating.
And you can see, I mean, you can understand, why would the cell want to eat itself?
Right.
Yeah, so at that time, they thought there was something going on. And then when Mortimer came up on board, and that was the person that really got me into the field, he realized that this process was activated when the cells were starved of amino acids. So he put 2 and 2 together, that indeed when the amino acids were low in the cell then was eating itself to provide the cell with amino acids. So he considered this process of autophagy more of essential for cell survival, so that the cells can survive various stresses, nutrient stresses.
Right.
And such. Then it got more interesting more and more years later. But anyhow, at that point in time, that's when I got interested in it, as to what was going on. It needed the cell biology approach, and I started working on it at Hopkins, and ever since after I left Hopkins, I've been at the University of Florida, which has really been very beneficial to me, because back then when I first started, the best way of examining and looking at autophagy was by electron microscopy. That's a big microscopes, high resolution microscopes basically, which not which only usually anatomy cell biology departments have.
Very interesting. So autophagy is self-eating, and it eats up all the parts of the cell that are maybe not in their most healthy form. Can you talk a little bit about what parts of the cell, in layman's terms, the autophagy is eating?
Okay, so basically the cell is composed of a variety of organelles. And organelles came up with that term came up based on relationship of our organ systems. Okay, the organ systems that we have in our body. So the cell has a variety of organelles: mitochondria, which makes the ATP, the energy, the nucleus, which has the DNA, endoplasmic reticulum and Golgi, which makes the proteins and assembles the proteins and such that are needed for the cell to survive and exist and function. Autophagy has the ability to degrade every organelle in the cell. It has the capability of removing any organelle that's damaged, any organelle that's aged, or any organelle that's inefficient. So autophagy can also be, it can be either selective and remove organelles selectively, or it can be non-selective and just eat the whole cell up, just piecemeal eating it up.
Right.
So non-selective is usually when you don't have amino acids. When the amino acids are low, the cell decides, I'm just going to chew up everything to provide myself with amino acids. Now, with aged or damaged organelles, yes, that becomes more selective. And that is really where a lot of the research is going on right now, trying to define how autophagy can be so selective.
It's almost as though autophagy is like the doctor of the cell, the doctor that says, okay, this part of the body isn't healthy enough, we're going to get rid of it, we're going to do this, and really controlling the health of the cell.
It is controlling the health of the cell, and they've worked quite a bit on how it identifies damaged mitochondria, but there's still a lot of research going on in how it removes some of the other damaged organelles.
How brilliant.
But mitochondria seems to be a key in a lot of processes, especially cell death. So if you can get rid of a damaged mitochondria, you can protect the cell from cell death, because mitochondria is the key for apoptosis, which is a form of cell death.
Right.
So these mitochondria that are damaged, you basically you engulf them into an autophagic vacuole or sequester them away from the cell, from the rest of the cell, and then throw them into the lysosomes. Everything gets degraded, no cell death.
So with this important self-eating autophagy that's within all of our cells, what happens to the autophagy process over time, or when we're affected by different pollutants or whatever it might be?
This is some of the cool things with autophagy. It's self-regulated, basically. So you turn on autophagy. You can turn on autophagy with damaging to organelles or, again, lack of amino acids. But autophagy will shut itself down, because once you degrade these organelles and everything, you release amino acids into the cell, and that shuts down autophagy. So autophagy has its own turn on and turn off mechanism.
Yes.
The turn off mechanism and the turn on mechanism via the amino acids, believe it or not, it's been looked at by Glenn Mortimer over 30 years ago, and we still don't know the signals as to why autophagy can be turned off by amino acids or turned on by the lack of amino acids. We don't know the specific signals. Since that time, there's a lot of drugs that came out that turn on and off autophagy and such. So some of those give us some answers as to what is actually regulating the autophagy pathway and what can turn it on and what can turn it off. The cell uses autophagy really to protect itself. It is a cell survival pathway. That's become more evident in the last 10 years. Before that, it was considered a cell death pathway, a way of killing the cell. But is now more of a cell survival pathway. Now, don't get me wrong, if autophagy goes on for too long, it will kill the cell.
Right.
And under those conditions, it's usually some sort of toxic agent or some sort of drug that continues to be around that sort of bypasses the amino acid inhibition. So it's carefully regulated.
Interesting. And you fast forward to 2016. Why do you think autophagy and the activation of autophagy really was the chosen Nobel Prize in medicine. Why do you think that is?
Nobel Prizes it's interesting how they pick Nobel Prizes. Nobel Prizes basically are based on one paper, not a number of papers.
Got it.
So this paper was a definitive paper to show that autophagy existed in the yeast model and opened up all sorts of things. It opened up pretty much all sorts of doors for a lot of different labs that were interested in this, but also when you start, it opened up the doors to identify the genes. And the genes opened up the doors to move everything to the mammalian system.
Understood.
And under the mammalian system, then you can start looking at the various genes or these proteins that are related to autophagy and see how they relate to diseases.
Okay, so let's really go there.
It was really the identification of a model system that will allow you to move on to looking at identifying the genes that are important for autophagy. Then you start thinking about, well, are these genes elevated, suppressed, under various disease states? And that's what really, everybody just started getting interested in that. Cancer was the first one. Everybody started getting interested in cancer. Actually, there was some immunological aspects too. Some people were interested in the immune responses and stuff.
And can you tell us a little bit about the doors that were opened up and why the Nobel Prize was won in medicine specifically?
I think the doors that opened up were really just opened up for a lot of other labs. And before the doors were opened, the labs just weren't interested in the field. They just weren't interested in looking at autophagy at the time because it was too difficult to study it. First it started with cancer. So it became interesting in cancer. So cancer, there was two basically fields of thought. One was the cancer cells shut down autophagy. And that will allow the cells to grow more because they're not degrading themselves. So they can build and grow faster and, and divide more.
The healthy cells or the cancer cells?
The cancer cells.
Got it.
The cancer cells. So one train of thought was the fact that with the cancer cells, the fact that they grow so well is they don't degrade, they don't eat themselves. So they grow real well. The other train of thought was the fact that the autophagy protects the cells. So there were two things that were actually going on. And actually both of those things are actually true now as well, depending upon the different cancers. When they were looking at the cancers, and they were looking at the chemotherapy agents, the effects of chemotherapy on the cancers, and they were seeing that some of these cancers were more resistant to the chemotherapy. So they started looking at, well, maybe it's the autophagy that's actually being activated to protect the cell. So with the LC3 marker, yes, they were seeing the autophagy actually turning on.
To protect the cell.
To protect the cell. So at that time, there were a number of inhibitors that were out there. None of them that were very specific, but there were a number of inhibitors out there. So these were compounds that were used routinely. So when they added these compounds in the presence of the chemotherapy agents, the cells were dying faster. That's because you shut down the cell protection by shutting down the autophagy. And that sort of really got people really interested in looking at ways of inhibiting autophagy.
With all of these new doors now being opened and all this additional interest, what is your hope, what is your dream of where this work, your life's work, will go over the next decade?
I'm hoping that we can regulate autophagy in such a way that we can cure some of the diseases or basically make the cells healthier to avoid the cancers, to avoid the pathogens that we are exposed to and such like that. Possibly we're getting back to aging again, really to make the cells healthier for longer periods of time and such. But that's a little tricky because you really at times you want to turn it off, but other times you want to turn it on. For aging, you sort of want to turn it on. You really want to basically help the cell or tell the cell that you really want to get rid of the old organelles and such like that. In older cells, the autophagy pathway is a little bit reduced. It's not as efficient.
Right.
So the idea is to activate it and turn it on. Now, during normal growth of the tumor, when the blood supply has yet to come in, the tumors are turning on autophagy to survive. So you would actually want to shut down autophagy at that particular time as well, before the blood supply gets to the tumor. So different conditions, you want to turn off autophagy. Other conditions, you want to turn on autophagy. So there's a big area now of looking at the role of autophagy in metastasis of the tumors. Not only inhibiting the tumors, but also in the metastasis of the tumors.
What seems to be very clear is that the activation or the suppression of autophagy is having an impact on cellular survival or death. And it's just a matter of the research continuing to figure out which compounds can be involved in that process.
Exactly right. You said it correctly. Autophagy basically, can turn on. You could turn it on or turn it off. It's going to have a variety of effects on cells, different cell types. That's true. So you got to be very careful of the side effects of such compounds that are going to either shut down autophagy or turn on autophagy, because of what they can do with other cell types and such, because autophagy is very critical. Autophagy is, again, turned on, if we haven't eaten in a while.
Right.
And once we wake up, autophagy is turned on. So that's a normal process. So if you have drugs, if you have people taking drugs that are shutting down autophagy, who knows how that's gonna affect really the normal processing in other cell types and other organs and such. So they're gonna have to be really careful in looking at side effects.
When you say we wake up in the morning, our autophagy is activated, and I've looked at different models of aging, for example, and autophagy is the activation of autophagy is such a big part of those different aging models. So you can see how as we age, our telomeres shorten, inflammation, all of these things, but really that autophagy is almost the foundational piece of this aging model.
Especially since the aging model is, what's critical about the aging model is that organelles are aging. They're old. They just don't survive, especially in cells that are non-dividing, like the neurons. Liver cells really don't divide that much. They can divide, but they don't divide that much. Cardiac muscle cells, they do not divide. So really these cells, they regenerate themselves, but they don't multiply. There's no division there. So they tend to accumulate damaged or old or aged organelles unless the autophagy is there to basically recycle them, degrade them, and then the cells can build new organelles. So that's kind of critical. That's very much critical. So again, when you wake up in the morning, you haven't eaten in a while, autophagy's kicked in. That's because your amino acid levels in the bloodstream are low.
Right. And for example, I'm intermittent fasting this morning, so I won't be eating probably until sometime later on this afternoon. And I know that the intermittent fasting is also helping to activate the autophagy in my body. And because my body is I hope, healthy, I'm getting that anti-aging, youth-activating cellular effect.
Yes, basically you're right. So sometimes the intermittent fasting is sometimes easier for some people than other people.
Right.
You're really pretty much starving when you wake up. You're really hungry when you wake up. But once you get past 9 or 10 o'clock, then it sort of seems to be okay. But you have to be engaged in something so you're really not even thinking about, boy, I'm hungry right now.
And you're intermittent fasting specifically to activate your autophagy?
Yeah. Yeah, mine is specifically to go after the autophagy.
Yeah.
Mostly with the heart and stuff like that.
Tell us a little bit about the heart.
Well, the heart, like I said, those cells are not dividing. And basically with the heart, which beats all the time and requires a lot of ATP, the mitochondria age relatively quickly compared to other cell types that don't require as much ATP as the heart does. So you really have to have a good functional autophagy pathway or a way of keeping it turned on to get rid of the damaged mitochondria or to get rid of the damaged organelles in the heart. So that's sort of one of the reasons I'm more interested in it, is really to give me a better, healthier heart.
Fascinating. So heart health, liver health, any of the organs or any parts of our body where the cells are not dividing, those are the organs or the cells that we really need to take the best care of and activate the autophagy in those types of cells.
Correct. The kidney was actually the most active in looking at, in turning on autophagy. And very few people are actually studying the role of autophagy in the kidney function and such, but it was looked at as being one of the most active organs turning on autophagy.
If you could sort of wave your magic wand and have an area of focus around autophagy and disease prevention where the researchers really put their attention there, where would you want the scientists to be working?
Mine would be more cancer. And basically I would think, the cancer I would pick would be the bone cancers, the osteosarcomas right now. The reason I'm keen on osteosarcomas is because that hits a lot of the younger people, the kids and such. I would love to see more focus on that. Aging, I don't know about aging. Aging is going to happen, unfortunately. I'm not sure how well you could slow it down. Not sure.
Dr. Dunn, it's just so fascinating to learn from you, and the work that you've done over the past 30 years is such important work, and it's a true honor to be able to sit and have this conversation. Thank you very much.
Oh, thanks for asking me.
You see, he's one of those unsung heroes that's doing all the grunt work, all the research work to prove this really, really does work.
I know, and I have so much respect for that kind of effort because through his work, he's able to blow the doors open for all of us to benefit from this kind of research, improve our health, improve our well-being, fight real diseases, and that's the kind of work he does every single day.
It's so good to be sharing it with everybody.